All right, in this example, we're being asked to find the sum of the following series. So this is 1 plus 2 plus 3 plus all the way up to 100. You're just going to keep adding these numbers. And so if we want to find the sum, the way you'd actually be expected to do this is that you would need to know the following formula. And the following formula is this. The sum as I goes from 1 to 100 of I. Call it, what this would mean is when I is 1, boop, pop it over, then set I to 2, and then do plus 2, and then I becomes 3, and you have plus 3. And so this big S, the Greek sigma right here, that actually represents sum. You're adding up all these numbers in between here. Now, this actually equals one individual formula, and I just realized I put 100 here. Let me put an n here, because I'm giving you the formula first. So as I goes from 1 to n, this is going to be equal to n times n plus 1 over 2. So if I'm doing this for this sum, n is going to be whatever your final number is, which in this case is 100. Hence, I put the 100 there. So this is going to be the sum as I goes from 1 to 100 of I. And so if I just pattern match with the formula right over here, n is 100. So I'm going to have 100 times 100 plus 1 all over 2. If we go ahead and simplify this out, 100 divided by 2 is going to be 50. And then 100 plus 1 is 101. And so if I multiply this out, you should get 5,050. Or, you could sit there and do 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 100, and you should get 5,050. Now, this is all well and cool, and if you already know the formula, you're set. That's also what you'll be expected to do. But if you're interested, where does this formula come from? Well, a mathematician named Gauss, he's not the one who thought to have discovered it, but he's the one who, rumored anyway, figured this out when he was, I think, about 10 or 12, somewhere in that age. And he was in school, and he had this really mean professor who just wanted to be left alone in peace so he could read his newspaper or his book and not actually have to teach anything. And so one day the professor goes, I know what I'll do. I'll just give all the students this task. I will ask them to add up all the numbers from 1 to 100. And then they can just sit there figuring that out. It's not hard, so they can't ask me any questions about what they're supposed to do. But it's also going to be very time consuming, so they can just do that for like an hour and I don't have to do anything. And so the professor gives this task to the class. Gauss sits here, he looks at it, he writes down the answer, and he puts it there after about 5 minutes. Professor's furious and he's waiting like, oh man, he just wrote down some random number so that he doesn't have to do the work. I'm going to get him later when everyone else turns it in. So everyone else turns in their results on top of Gauss's, so Gauss is on the bottom. When the class ends, the professor scoops them up and flips them over, and he looks at this kid's answer, 5,050, as it should be. How did Gauss do that? Well, he's not a human calculator. Maybe he was, but that's not how he figured this out. He didn't just sit here and go, ooh, I can add that, woo, and go through it like a computer would. He just got clever about it. So let's sort of look at what's going on here. Say I want to add up the numbers 1 to 100. So I've got my sum is going to be 1 plus 2 plus 3 plus 4 up to 100. Well, let's see how clever we can get with this. If I were to take this same sum and add it again, so 1 plus 2 plus 3 plus 4 up to 100. Well, what's interesting here is that if you wanted to add these, you could. You just get 2, 4, 6. Doesn't seem very helpful. But what if instead of writing it this way, I actually wrote it the other way around? So let's ignore this top one here. I'm going to put the sum, but I'm going to write it the other way around. So this is going to be 100 plus 99 plus 98 plus 97 all the way down to 1. And now if I add these, well, what happens here? 1 plus 100, that's 101. 2 plus 99, that's 101. 3 plus 98, that's 101. And so you're just going to get a whole bunch of 101s. And notice I added s twice, so that's going to be 2 times the sum. And so I've got 101 here. Well, how many times do I have 101? How many times does this number repeat? Well, we were adding up the numbers 1 to 100, right? That's 100 numbers. 1, 2, 3, 4, all the way up to 100. That's 100 times that I've got 101. So 101 happens 100 times over here. So this is 2 times this sum equals 100 times 101. And then I just need to solve for s, so divide both sides by 2. Well, would you look at that? And of course, if you just change the 100 to an n, then you can do this exact same process and you can come up with this formula. Now, Gauss being a kid, the cleverness here, the part that made him like one of the greatest mathematicians ever, is not that he was a calculator. It's not that he could look at numbers and just add them up really quickly, but that he could see how the numbers were behaving and see this pattern. And considering how quick he did it, he probably didn't even sit here and do all this. He probably just looked at it, recognized that if I have 1 to 100, I add those, 2 to 99, and if I just do that visually, he just recognized that this will be your answer, just going through this sort of thought process. Us mere mortals, of course, have to write this out and think it through. So that's the example. What you would actually be expected to do for most of your classes is just know this formula. But here's how you can see that these formulas do come from somewhere. There's a reason and a logic to them. So that's this example. Adding up the numbers from 1 to 100 is 5,050.